Hello everyone, welcome back to my channel. This is the third part of higher order derivative, in which in the previous class we have discussed about the standard forms of higher order derivative. In this video we will learn about the Leibniz rule, or which is also known as Leibniz theorem. So here is the definition for the Leibniz rule. It is given that if f of x and g of x are the two different functions of x, then the nth order derivative of f of x and g of x can be calculated by using the Leibniz theorem. So suppose consider we have two kinds of functions. Let us consider the f of x function is our x square, and then g of x value is nothing but our sin x value. So these are the two functions will be given to us, and we can find the what we say is a Leibniz theorem. By using Leibniz theorem, we can also find the nth order derivative of the particular function which is given to us. So what is Leibniz theorem's formula? So this is what the formula: d by dx f of x g of x. So this will be given to us. So this is the given part in the question. You will get this part, and the formula is nc0. That means permutation and combinations. From that we got nc0 dn by dxn f of x. That means we have to do the derivative for the f function, and we consider this g of x. That means the g of x remains the same for the first derivation, then plus nc1 derivative of n minus 1. That means one step is decreased here. That means the derivative will decrease by n minus 1 f of x. Then the g of x will get derivated in this step. That means d by dx of g of x plus nc2 d to the power n minus 2 dx n minus 2 f of x, then d square by dx square g of x, and so on till we can write it as the formula ncn d to the power n minus n by dx n minus n f of x d to the power of n by dx to the power of n gx. So here we have to know some terms. That means in the formula it is given f of x. So if the function is given, two kinds of functions are given, what we have to consider? So f of x will be our recurring function. So here I am writing as f of x will be the recurrence function. That means the function which we have the repeated values we have to consider as a f of x. Like example, if the what we say, if the function or the if the function is given in the form of sin x, cos x, and so on. So these are the repeated value. If you do the derivative, we get only the similar steps. So that's what we take f of x as a recurrence function, and then g of x is known as non-recurrence function. So this is the function where we get the value as 0 after taking n number of derivatives. Like example, if we take the example as x square, 3x cube, or 2x plus 1, if you do the derivative for 1 or 2 steps or up to 3-4 steps, we get the values 0 after the nth kind of derivative. So this is f of x we have to consider as a recurrence functions where we get the repeated value, and g of x we will consider the function where we get a constant value after some derivative steps. Also, if you see here, there is a values nc0, nc1, nc2. For those values, we can consider it as, like, by taking nc0 value is 1, and then nc1 is the value which is equals to n, and again nc2 value is n into n minus 1 by 2 factorial, which we have learnt in our higher secondary classes, and then nc3 the value will be n into n minus 1 n minus 2 by 3 factorial. So for this up to nc3 is enough. That means we get up to nc3 only. So I have taken, if you have nc4, then you can write it as n into n minus 1, n minus 2, then n minus 3 upon 4 factorial. So like that we can write the values for these combination values. And next there is one more functions are given, that means formulas what we have to write. If you see here, the derivative of f of x, nth order derivative f of x, and again if I write the function for nth order derivative, nth order derivative of sine x, so the answer will be sine n pi by 2 plus x. So this is what we have for the nth order derivative of sine x. And similarly for the derivative of nth order derivative of cos x is equals to cos n pi by 2 plus x. Then the one more nth order derivative formula is, that is e to the power of ax, which is equals to a to the power of n into e to the power of ax. So these values we will substitute in the given questions to get the answer. So let's do one question based on this topic. So the first question is, the question is given to find the yn, that means nth order derivative of the function called, so here the function is given x square sin x. So here we have to consider, let's start the solving this question. So here I will consider f of x, which is a recurrence function. So sin x is our recurrence function, because if I do the derivative of sin x, we get the value as cos x. Again, by doing the derivative for cos x, I get the answer as minus sin x. If I do the derivative for minus sin x, again I get the answer as minus cos x. So here it is a recurrence function. So f of x is a recurrence function. Then the g of x is a non-recurrence function. So here it is, the non-recurrence function is nothing but x square, because the derivative of x square is 2x. Again, doing the derivative for 2x, I get the value as 2. When I do the derivative for 2, the constant value, I get the value as 0. So this is our non-recurrence value, because the values doesn't repeat up to nth order, nth derivative time. So this is what I have. Now I will write the Leibniz rule, that is dn by dxn. The function is given sine x into x square. So this is what we have. Now the formula nc0, then derivative of dn by dxn. Here we have a f of x. So f of x is nothing but our sine x. So sine x, and we keep the g of x as similar, that is x square plus nc1. And again we let me write this one in the next step. Then again we have nc1. Now we decrease a step, and the derivative, that means derivative of n minus 1 by dxn minus 1. Again we have a sin x formula, that means f of x, and d by dx of g of x. Here g of x is nothing but x square. Then again we have a step nc2 dn minus 2 by dxn minus 2 sin x d by dx d square by dx square of x square. So here up to you may get a doubt up to which step we have to consider this one. So if you see the g of x function, g of x is nothing but it is given x square. So first time derivative we get 2x, and in the second derivative we get 2, and in the third derivative we get the value 0. So up to second derivative we have to write the Leibniz rule. That means we have to write up to nc2 value only. It's depending on the g of x values. So I have written the up to nc2. Now I will substitute the values and I will solve the derivative part to get the answer. So nc0 value is 1. So 1 into the derivative of nth derivative of sin x is sin n pi by 2 plus x, and the x square we write it here, then plus again nc1 values which I have already written here, you may check it out. nc1 value is n, so plus n. Again the derivative of n minus 1 of sin x. So for this I can write, in place of n I will write n minus 1. So sin n minus 1 pi by 2 plus x, and the derivative of x square is 2x. Then the next step, nc2 is the value which we have is, if you see here which I have written, it is n into n minus 1 by 2 factorial. The same I am writing here, n into n minus 1 by 2 factorial. Then again I have the derivative of n minus 2 of sin x. So that answer, in place of n I will replace n minus 2. So I can write it as sin n minus 2 pi by 2 plus x, and then the derivative, second time derivative of x square will be 2. So for this I can write the value as x square. On rearranging this equation I can write x square, then sin n pi by 2 plus x, okay, then the value 2xn sin n minus 1 by 2 pi plus x, and then the remaining is n into n minus 1. Here if you see, these two values will cancel out, 2 factorial and 2 will get cancelled out, and then n into n minus 1, then sin n minus 2 pi by 2 plus x. So this is the answer for the given question. Now let's solve one more question based on this topic. So next, the second question is given. The question is given that to find y an nth order derivative of the function called x cube cos x. So I will just explain the step, and the other things you will do it by yourself. So here we will consider f of x as, here the f of x will be the cos x and the g of x is x cube. So when I do the derivative for the x cube, I get the derivative of x cube as 3x square. So the derivative for the second time I get 6x, and the derivative for the third order, then I get the value 6, and fourth time I get the value 0. So I will take nc3 up to step called nc3. Since here it is given up to nc3 only we have the value, after that we got the value as 0. So for that I can write the Leibniz theorem as dn by dxn f of x into g of x, that is cos x into x cube, which is equals to nc0 nth derivative of dn by dxn cos x and then gx cos x and then gx, which is x cube, plus nc1 dn minus 1 by dxn minus 1 cos x, then derivative of x cube, and in the next step nc2 derivative of n minus 2 by dxn minus 2 cos x, then derivative of d square by dx square of x cube, and again the last one nc3 dn minus 3 upon dxn minus 3 cos x, then d cube by dx cube x3. So this is what we have the formula of Leibniz rule. Now we will substitute the values. So the values which we having are, so the values are nc0 value is 1, and I have written the nth order derivative of cos x will be written as cos n pi by 2 plus x and then x cube plus nc1 value will be n, and again in place of n I can write the value as cos n minus 1 pi by 2 plus x, and the derivative of x cube will be 3x square. Then in this step I can write the value as n into n minus 1 by 2 factorial, and the derivative can be written as cos n minus 2 pi by 2. Then what we have to write is pi by 2. Then here we have the derivative for the x cube for the second time, so I can write it as 6x again, plus for nc3 we have the value n into n minus 1 n minus 2 upon 3 factorial, then cos n minus 3 pi by 2 into 6. So on rearranging these values we can get the answer, that is the answer will be x cube, then cos n pi by 2 plus x, then plus 3x square n cos n minus 1 pi by 2 plus x, plus here we cancel out the value, that means 2 factorial, so this 2 factorial, and here we get 3, that means 2 1 2 3 times. So the next step will be 3x n into n minus 1, then cos n minus 2 by 2 into pi. So here I have to write the value x, I just missed the value as x, plus x. Then again we have here 3 factorial, so on cancelling we get here 2, so which is equals to, on cancelling, okay, here we have a 3 factorial, right? So here we get the value 6 only on cancelling. That means the next step will be written as the next step will be written as plus n into n minus 1 n minus 2, then cos n minus 3 pi by 2 plus x. Here also, just change it out. Here also we have plus x, then 6. Here the 6 will get cancelled out. So the answer will be x cube cos n pi by 2 plus x plus 3x square n cos n minus 1 pi by 2 plus x plus 3x n into n minus 1 cos n minus 2 pi by 2 plus x, and then n into n minus 1 n minus 2 cos n minus 3 pi by 2 plus x. So this is the answer for the given question. Now, as we have the other question, which is called, the question is given to find the nth order derivative of the function, given that the function is given to find the nth order of x cube plus 1 e to the power of 2x. So for this we can write the f of x and g of x as, here the f of x will be the recurring function, that is e to the power of 2x, and the non-recurrence function is x cube plus 1. So these are the functions which we got, and then as we know, nth order derivative of e to the power of ax, where I have written the formula for sine, cos. See here, sine, cos and e to the power of ax. So in this question we will use the nth order derivative of e to the power of ax. So for that, let's write the Leibniz theorem. So dn by dxn, the function e to the power of 2x into x cube plus 1. Now nc0, nth derivative of f of x. So here the f of x is e to the power of 2x into gx. Here the gx is x cube plus 1. So y is equals to x cube plus 1. y1 will be equal to 2x square. y2 is equals to 4x and y3 is equals to 4. So we will take up to nc3. Then the next will be written as nc1 dn minus 1 by dxn minus 1 e to the power of 2x, then d by dx of x cube plus 1. Again nc2, the derivative of n minus 2 by dxn minus 2 of e to the power of 2x, d square by dx square x cube plus 1. Again in the next step, nc2, derivative of dn minus 3 by dxn minus 3 e to the power of 2x, then d cube by dx cube x cube plus 1. So this is what we have the Leibniz theorem. Now we will substitute the values. So on substituting, the nc0 value is 1 and the derivative of e to the power of 2x. So for that we have a formula, that means dn by dxn is equals to e to the power of ax is d nth derivative of e to the power of ax is equals to a to the power of n into e to the power of ax. So this is what we have a formula. So for that, here if you see, a is nothing but a is equals to 2. So according to that, I can write the value as like 1 equals to, for this nth order of e to the power of 2x, so e to the power of 2x into 2n, because here a value is 2. So 2 to the power of n into the gx value, that means 3x plus 1. Then plus again nc NC1 value is n. So for the NCn value 1, then the n minus 1th derivative of e to the power of x will be written as e to the power of 2x into 2 to the power n minus 1, and the derivative of this function will be 3x square plus, again NC2 value is n into n minus 1 by 2. And for this derivative, I can write the value as e to the power of 2x into 2 to the power n minus 2. Again, the derivative of this value will be 6x square. And the last one, NC3. Here it is NC3. So NC3 will be written as n into n minus 1, n minus 2 by 3 factorial. So for 3 factorial, then here I have the value e to the power of 2x into 2 to the power n minus 3 into 6. So here we have the value called 6. That means after the derivation, for the first derivative we got 3x square, and for the second derivative we got 6x, and for the last one we got the value as 6. So now we will arrange these values. That means on arranging this one, I can write the last step of this question as 2 to the power of n e to the power of 2x, then x cube plus 1 plus 3x square n, on multiplying these values, then into 2 to the power n minus 1 into e to the power of 2x, plus on solving these values I get here the next step it as, see here the 2 factorial, so this value will cancel out this 2 factorial with the, so on cancel outing we got the value here as 3. So here the value will be 3n x n minus 1. Otherwise we can flip it out like 3x n into n minus 1 into e to the power of 2x into 2 to the power n minus 2 plus, so here also we can cancel out the value, that means 3 factorial and 6 will get cancelled out, and the remaining will be n into n minus 1, n minus 2, 2 to the power n minus 3, e to the power of 2x. So this is the answer for the given function. So these are the 3 types of questions where we get, here if you see, this is in the form of e to the power of 2x, and the second question was in the cos x form, and the first one is in the sin x form, where we can use the Leibnitz theorem, and we also have the formulas for each of the nth order derivatives, and along with that we have the values for combination values, that is for NC0, NC1 and for NC2 and so on. And also we have discussed how to take the f of x and g of x. For f of x we have to check for the recurrence function, and for g of x we have to take the non-recurrence function, where we get the value as a constant up after doing nth order derivative. So this is what we have discussed about the Leibniz theorem. That's it for today. Thank you.